Hello viewers, how are you? Welcome to my channel Physics with Rams. So today we are going to start a new chapter, thermal properties of matter. So before going to start this topic, those who are new to my channel, please subscribe my channel so that you can receive notifications regarding my channel, as well as watch my previous videos so that you can clear your concepts and you can solve as many numericals as you can based on these concepts. Let's start this topic. Here in this video we are going to discuss about heat and temperature. What is meant by heat and what is meant by temperature, as well as what are the different types of scales we use in order to measure the heat as well as temperature. Come to the case of this heat. Heat is nothing but it's a form of energy which represents the sensation. So here we can represent that heat is a form of energy. And heat is measured based on a calorimeter. Come to the case, the unit for heat is nothing but calorie in CJ system, as well as joule in SI system. And here 1 calorie is defined as the amount of heat required by water, 1 gram of water, to rise its temperature from 14.5 degrees Celsius to 15.5 degrees Celsius. That represents the definition for calorie. So here heat is nothing but it's a form of energy and which represents a sensation. Let's discuss about temperature. What is meant by temperature means temperature represents the amount of hotness or coldness of the body. Means if we touch a body, here we can represent that the body is hot, or if we can touch another body which might be a cool. Means we can, by touching the body itself, we can represent that the given body is hot or cold. We have to represent the temperature. What is the amount of hotness of the body, or what is the amount of coldness of the body, is being represented based on this temperature. So here temperature is nothing but it represents the amount of hotness or coldness of the body in an exact value. So here this temperature is being represented based on a steam point as well as ice point. Steam point and ice point of water. Come to the case, if we consider the Celsius scale, then the steam point for Celsius scale is 100 and ice point is 0. So here we represent it as 100 degrees Celsius as well as 0 degrees Celsius. In between 0 to 100 we have 100 divisions. So every division represents 1 degree. Whereas when we consider Kelvin scale, the steam point for Kelvin scale is 373 K, whereas the ice point for Kelvin scale is 273 K. In between 273 to 373 we have 100 divisions. Whereas other than that we have Fahrenheit scale. Come to the case of this Fahrenheit scale, the steam point of Fahrenheit scale is 212 degree Fahrenheit and its ice point is 32 degree Fahrenheit. So assume that in between 32 to 12 we have 180 divisions. So these are the common scales we use in the case of representing the temperature, and we know that the heat is being transferred from high temperature body to low temperature body. Means here we can represent that if the temperature of a body is represented as T2 and the temperature of this body is T1, and here we consider that T2 is greater than T1, then we can represent that the heat is being transferred from this body to this body until they attain a common temperature. Come to the case here, in order to convert from one scale to another scale, we have a formula, and the formula is represented as a given temperature minus lower fixed point by upper fixed point minus lower fixed point. So based on this equation, we can convert from one scale of temperature to another scale. So let us consider how to convert from Celsius to Kelvin. Then the expression can be represented as if we consider the given temperature as T suffix C in the case of Celsius scale, and its lower temperature, lower fixed point is 0 by upper fixed point is 100 minus lower fixed point is 0, which is equals to, in the case of Kelvin, let us consider that temperature is given as T suffix K minus 273 by upper fixed point is 373 minus 273. Observe that here the expression can be represented as T suffix C minus 0 is nothing but T suffix C. T suffix C by 100 is equals to T suffix K minus 273 by 100. Observe that 100 gets cancelled. So based on this, we can represent that T suffix C is equals to T suffix K minus 273. Means if a temperature is given in terms of Kelvin, then we have to convert it into degree Celsius. Then the expression is T suffix C equals to T suffix K minus 273. Suppose if the temperature is represented in terms of degree Celsius, then we have to convert it into Kelvin. Then the expression is T suffix K equals to T suffix C plus 273. So by using this expression, we can convert the given temperature in Kelvin as into degree Celsius. Next, let us convert from Celsius to Fahrenheit. Observe the expression. Given temperature is nothing but T suffix C minus 0 by 100 minus 0 is equals to temperature in terms of Fahrenheit is represented as T suffix F minus 32 by 212 minus 32. Observe that 212 minus 32 is nothing but 180. So the expression can be represented as T suffix C by 100 is equals to T suffix F minus 32 by 180. 9 2s are 18 as well as 5 2s are 10. So based on that, here we can use this expression in order to convert from Celsius to Fahrenheit or Fahrenheit to Celsius. T suffix F minus 32 by 9. Take a screenshot, we will continue. Let's solve some numericals based on the given formulas. Observe the first problem. Convert minus 10 degrees Celsius into Fahrenheit scale. And here we know the formula for Celsius and Fahrenheit is C by 5 is equals to F minus 32 by 9. So here minus 10 degrees Celsius, temperature in Celsius scale has been given as a minus 10. So when we substitute this, minus 10 by 5 is equals to F minus 32 by 9. Observe that 5 2s are 10. And when we multiply 2 with 9, cross multiplication, here we get F minus 32 is equals to minus 18. So here F is equals to 32 minus 18. So here when we subtract, observe that 14 degree Fahrenheit. So minus 10 degrees Celsius represents 14 degree Fahrenheit. Now observe the second problem. Show that minus 40 degree measures the same temperature on Celsius and Fahrenheit scale. Come to the case of this. Here I am going to consider the temperature in the Celsius scale as x. X by 5 is equals to x minus 32 by 9. Since they are same on Celsius and Fahrenheit, I had considered it as x. So when we cross multiply this expression, observe that 9x is equals to 5x minus 32 into 5. 5 2s are 10, 5 3s are 15, nothing but 160. So here, when we send this 5x towards this side, then expression can be represented as a 9x minus 5x is equals to minus 160. So 9x minus 5x is 4x. 4x is equals to minus 160. So x is equals to minus 160 by 4, nothing but minus 40 degrees. Observe that minus 40 degrees is same in the case of Celsius as well as Fahrenheit. Observe the third problem. What is the temperature for which the Kelvin and Fahrenheit scales are same? And here the relation between Kelvin and Fahrenheit is K minus 273 by 5 is equals to F minus 32 by 9. So here we had represented that the temperature is the same. The temperature is same. So based on that, here I am going to consider it as x minus 273 by 5 is equals to x minus 32 by 9. 32 by 9. So now when we cross multiply this, observe that 9x minus 273 into 9. 9 3s are 27, 2, 9 7s are 63. 63 plus 2, 65, 9 2s are 18. 18 plus 6, 24 is equals to 5x minus 160. So send this 5x towards this side and bring this 2457 towards this side. Observe that 9x minus 5x is equals to 2457 minus 160. So 4x is equals to 2200. Observe that here 15 minus 6 is 9, 7. So x is equals to 2297 by 4. 4 5s are 20. So 4 7s are 28. And again 4 4s are 16. Still we have 1. 4 2s are 8. So it continues. So approximately we can represent it as a 574.2. So at this temperature, Kelvin as well as a Fahrenheit scale represent the same temperature. Take a screenshot. We will continue. Now we are going to discuss about thermometry. Thermometry is the process which deals with the measurement of temperatures by using different methods. The first method is a resistance thermometer. Resistance thermometer. And here we can also represent a constant volume thermometer. Constant volume thermometer. As well as we can also represent a mercury thermometer. Mercury thermometer. So come to the case of these thermometers. Already we had discussed about a mercury thermometer. Mercury thermometer is nothing but it's a liquid thermometer. Based on the expansion of volume, we represent the temperature which we regularly see in hospitals as well as different places. Alcohol thermometer is also there, which also represented based on the expansion of the liquid. Now we are going to discuss about resistance thermometer. Here in the case of this resistance thermometer, we consider platinum material. So when we consider platinum rod, here when this rod has been heated, when we heat this rod, the vibrations increases. The vibrations increases. As the vibrations increases, its resistance increases. Resistance increases. So the increase in the resistance with respect to initial resistance is represented as a delta R, increase in the resistance, equals to R naught into initial resistance into alpha into change in the temperature, delta T. Whereas delta R is nothing but a change in that resistance, means resistance at a given temperature minus resistance at 0 degrees Celsius is equal to resistance, initial resistance R naught into alpha. Change in the temperature is at a given temperature T minus 0, nothing but T. Now, so here when we consider the same platinum resistance thermometer based on ice point and steam point, the expression can be represented as R of 100 minus R naught is equals to R naught into alpha T into 100. Why? Because change in the temperature is 100 minus 0, nothing but 100. So when we divide both these equations, we can represent the expression for temperature. Observe that observe that R suffix T minus R naught by R of 100 minus R naught is equals to R naught alpha T by R naught alpha into 100. Observe that R naught alpha gets cancelled. From this, T is equals to R suffix T minus R naught by R of 100 minus R naught into 100. So this is the expression given for representing the temperature based on platinum resistance thermometer. Similarly, we can also represent a thermometer based on constant volume, and the expression for constant volume thermometer is given as a T is equals to pressure at a given temperature minus pressure at a 0 degrees Celsius by pressure at 100 degrees Celsius minus pressure at 0 degrees Celsius into 100 in terms of degrees Celsius. So this represents the temperature for constant volume thermometer. Similarly, we can also represent the expression in terms of length for mercury thermometer, whereas it is given as a T is equals to length at a given temperature minus length at 0 degrees Celsius by length at 100 minus length at 0 into 100 degrees Celsius. So by using this formula, we can measure the temperature. Take a screenshot, we'll continue. Now we are going to solve some numericals based on these thermometers. Observe the first problem. Here the resistance has been given as a 3.50 ohms at 0 degrees Celsius, as well as the resistance at 100 degrees Celsius is 3.65 ohms, and the temperature has been represented as minus 37 degrees Celsius. Now we have to find the resistance at this temperature at 37 degrees Celsius, and we know that T is equals to R suffix T minus R naught by R of 100 minus R naught into 100. So by using this formula, we have to find the resistance at this temperature. Observe that minus 37 is equals to R suffix T minus 3.5 by 3.65 minus 3.5 into 100. So now Here observe that minus 37 is equals to r suffix t minus 3.5 by 0.15 into 100. 5 2s are 10 and 5 3s are 15. 5 3s are 15. So when we send this 0.03 and 20 towards this side, the expression can be represented as r suffix t minus 3.5 is equals to minus 37 into 0.03 by 20. So now observe that 37 into 3, 7 3s are 21, 3 3s are 9, 10, 11. So observe that we have to place a decimal point after 2 digits, 1.11. So here r suffix t minus 3.5 is equals to minus of 1.11 by 20. Or we can represent it as 0.311 by 2. So when we divide this, 0.05, 5 is a 10, again it continues to 0.05. So here then observe that r of t minus 3.5 is equals to minus of 0.055. So based on that, resistance at the given temperature is 3.5 minus 0.055. So the expression can be represented as 3.455. So this is the resistance at this temperature. Now after the second problem, pressure at 0 degrees Celsius is 50 centimeters of mercury and pressure at 100 degrees Celsius is 90 centimeters of mercury and pressure at the given temperature is 60 centimeters of mercury. Now we have to find the temperature. So we know that T is equals to P minus P naught, nothing but 60 minus 50 by 90 minus 50 into 100. So 60 minus 50 is 10 by 90 minus 50 is 40 into 100. So observe that 0 gets cancelled. Next, for 2 2s are 4, 5 2s are 10, and next 2 1s are 2 and 2.5. 2.5 into 10 is nothing but 25. So the temperature is represented as 25 degrees Celsius. 25 degrees Celsius. Okay, screenshot. Please give a like to this video, share this video to your friends and don't forget to subscribe my channel.